Looking to build a live weather dashboard right in your console? Today, we're diving into Rust to build a real-time weather tracker using the OpenWeather API. Whether you're learning Rust or just want a cool project, this will help you interact with APIs, handle JSON, and format data in the console. Let's get started. First, create a new Rust project. Before we start coding, we need to make sure we have the necessary libraries installed. We specify these dependencies in the cargo.toml file. We will use request to make HTTP requests to the OpenWeather API. We've included the JSON feature to enable easy parsing of JSON responses. SERD library provides tools for serializing and deserializing data between Rust structs and various formats, primarily JSON in our case. The derive feature allows us to easily derive serialize and deserialize traits for our structs, making it convenient to work with JSON data. SERD JSON provides specific implementations for working with JSON data within the SERD ecosystem. Tokio provides an asynchronous runtime for Rust, allowing us to write concurrent code efficiently. The full feature includes all the necessary components for our application. Now let's break down this code step by step and understand how it fetches weather data. First, we have these use statements at the beginning. These lines basically tell Rust to import functionalities from libraries that we'll be using in our program. Then, we have these two constants. API key stores our unique API key to access weather data from OpenWeather, and base URL holds the base URL of their API. You'll need an API key from OpenWeather. Once you have it, define the API endpoint and API key. Replace your API key with your actual API key. Next step is to define the structures that match the JSON response from the OpenWeather API. We have three structs here: weather response, main, and weather. The weather response struct is like a blueprint for the overall weather data we'll get back. It has three fields: main of type main, which holds information like temperature and humidity; weather of type vector weather, which is a vector, basically an array, that can store multiple weather conditions; and name of type string to store the city name. Similarly, the main struct is a blueprint for the main field within the weather response. It has two fields: temp of type F64 to store the temperature in floating point numbers, and humidity of type U8 to store humidity as an unsigned 8-bit integer, between 0 and 255. The last struct, weather, is simpler. It has a single field, description of type string, to store the weather description, like cloudy or rainy. Next, we have a function called fetchWeather. This function takes a city name as input and tries to fetch the weather data for that city using an asynchronous approach. Async/await is a way to handle tasks that take time to complete without blocking the main thread of execution. Inside the function, we first format the URL using the city name, API key, and base URL. Then, we use the get function from request to make a get request to that URL. The await keyword tells Rust to wait for the response before proceeding. Once we have the response, we use the JSON method to parse the JSON data from the response into a weather response struct. Again, await is used to wait for the parsing to finish. If everything goes well, the function returns an OK variant containing the parsed weather response data. But if there's an error during the process, it returns an error variant containing the error details. Now we have the display weather function. This function takes a reference to a weather response struct as input and simply prints the weather information to the console in a formatted way. It prints the city name, temperature, humidity, and weather description. To fetch the weather data at regular intervals, we have the main function, which is the entry point of our program execution. Here, we define a city name. You can change this to any city you like, and create a Tokio runtime, which is an environment for running asynchronous tasks in Rust. Then, we use a loop to continuously fetch and display the weather data. Inside the loop, we call the fetchWeather function and wait for its result. If the weather data is fetched successfully, we call the display weather function to display it. But if there's an error, we print an error message. After displaying the weather, the program waits for 5 seconds using sleep function from Tokio time before fetching the weather data again. This creates a real-time weather dashboard that updates every 5 seconds. If you run this code, it will display the current temperature, humidity, and weather condition of your chosen city, updating every 5 seconds. If you enjoyed this video, you will definitely love to watch other quick coding challenges on this channel. See you in the next video, and happy coding!